This lesson will continue our exploration of nonparametric tests, but with tests where two groups are being compared. The Wilcoxon signed rank test is another nonparametric test that uses ranks to compare the paired difference of the medians of two groups to 0 and to compare a median to a target value. Its parametric equivalent is the t-test for paired treatment. As you recall, the sign test is used for a similar set of circumstances. However, the sign test uses only the signs of the differences. Wilcoxon's signed rank test also includes the magnitude of these differences. This additional information makes Wilcoxon's signed rank test a more powerful test in uncovering the true nature of the data. The assumptions for this test are few. We must have simple random samples. Also, the distribution of the differences of the data should be bell-shaped. To find the test statistic, we deploy a similar tiered function approach. If the sample size is at most 30, we use the smaller of the sum of non-zero difference ranks between positive and negative. If the sample size exceeds 30, we still calculate the t-value, but we need to convert to a z-score using the formula shown. Consider this example. Suppose we look at penalties between a Little League football team and a Little League soccer team. The rows of data are paired by year. We wish to determine if there is a difference in penalties for football and soccer. We calculate the Wilcoxon statistic to be 17. The corresponding p-value is 0.3077. Therefore, we fail to reject the null. There is no difference in the penalties between football and soccer. The Mann-Whitney test is a nonparametric test that uses ranks of sample data from two independent populations to test the equality of medians. Its parametric equivalent is the t-test for independent treatment. The null statement is that the population medians are the same for two independent samples. The alternative statement is that the population medians are different from two independent samples. We can also establish that one median is greater than or less than the other on the alternative statement. The assumptions for this test are simple random samples, and each of the samples must have 10 or more values. The test statistic is essentially a z-score. It is a standardized sum of ranks of the sample with size n1. The mean and standard deviation are given by the formulas shown based on the sample sizes of each group. Let's consider this example. We have two independent samples, a control group and a treatment group. We wish to determine if the medians of the two groups are different. Assume alpha is 0.05. Using technology, we get a test statistic of plus or minus 1.78033. Since the alternative is difference, this implies a two-tail scenario. When we find the area in the tail under the normal, we must double this value to get 0.07445 for the p-value. Since the p-value is bigger than 0.05, we fail to reject the null. The medians are the same. Recognize that many statistical packages report two test statistics called the maximum and minimum Mann-Whitney U. If this happens, you can use the formula shown here to convert to a z-test statistic. Here, N1 and N2 are the respective sample sizes of the two groups. When the larger of N1 or N2 exceeds 20, the U distribution quickly becomes normal. Please pay attention to the alternative statement to determine the number and sign of the test statistic. Spearman's correlation is a non-parametric test that uses the ranks of sample data consisting of matched pairs. It is used to test for an association between two variables. The null statement is there is no correlation between the two variables. The alternative statement is that there is a correlation between the two variables. The assumptions for this test are a simple random sample, and each of the samples must have 10 or more values. A non-parametric test, Spearman, does not require a normal behavior. It can also be effective in uncovering some nonlinear relationships. When finding the critical values for Spearman's rho, if the number of pairs is less than 30, we can use technology or tables to find a critical correlation based on the number of pairs and alpha. When the number of samples exceeds 30, the critical value is the z statistic divided by the square root of the number of pairs minus 1. As always, we can always find the p-value and compare to alpha. Spearman's test is best performed with technology. As part of this output, we will obtain a p-value. The formula for the test statistic emulates that for the Pearson correlation. Take note that the data for the x's and y's must be converted to ranks unless it is already ranked. This version accounts for ties in the ranks. If we have no ties, the formula simplifies significantly. Here D represents respective differences between each pair. N is the total number of pairs. Suppose we are given the following paired rank data. Assume alpha is 0.05. We can use technology to find Spearman's rho to be negative 0.63874,289. The p-value is found to be 0.0104. Since the p-value is smaller than alpha, we reject the null. There is a significant correlation between these two ranked variables.